In this video, we are going to talk about Boyles Law. This is the first of the gas laws that you'll encounter. The law states that for a fixed amount of gas at constant temperature, the pressure and volume of the gas are inversely related. What does that mean? Well, that means if one of the quantities goes up, the other has to go down. So, as pressure goes up, the volume must go down. If the volume goes up, the pressure must go down. Another way to state this is that pressure times volume is equal to a constant. And we're going to call that constant K. So we can see in this picture we have a cylinder with a movable piston. If I were to press down on that piston so that the volume goes from 2 liters to 1 liter, the pressure has to double. You see it goes from 1 atmosphere to 2 atmospheres. Decrease in volume, increase in pressure. Now that makes sense because as you're pushing down on this, it's going to get harder and harder to push down, right? Because the gas is pushing back on you. So all of those collisions with the container that cause a pressure makes it harder and harder for us to push down on that cylinder. Now, we can have differing conditions. Now, this is actually probably the best way to state Boyles Law, is that you have P1 V1 is equal to P2 V2. What does that mean? That if you're changing either the pressure or the volume of a gas, you can calculate what the new quantity will be. So here's an example problem on Boyles Law. What is the new pressure of a gas if 2.5 liters of gas at 3.1 atmospheres of pressure is allowed to expand to a volume of 12.3 liters? Well, in all of the gas laws, and actually in all of our problem solving, the best thing that we could do is we could list what we know and what we don't know. Now, with the gas laws, it's going to become very, very, very important that you list out your quantities and you give them a name. So let's take a look at what quantities we've got. We've got 2.5 liters of gas. So volume 1 is equal to 2.5 liters. And the pressure was 3.1. So P1 is equal to 3.1 atmospheres. Now it says, what is the new pressure? So that would be P2. What is the new pressure? I don't know. So that's the question mark. And then the volume 2 is equal to 12.3 liters. Now to determine who's volume 1, who's volume 2, who's pressure 1, who's pressure 2, you really have to read the problem carefully. This says, what is the new pressure? So that means that it's the second pressure of a gas if 2.5 liters of a gas at 3.1 atmospheres is allowed to expand to a volume. So that means that that volume must be volume 2. Therefore, the other two quantities must be our volume and pressure 1. So once we've got our pressure 1, our volume 1, our pressure 2, and our volume 2 listed, we can write our equation. P1 V1 is equal to P2 V2. Now, you're going to be tempted to go ahead and just plug in the numbers right now, but I'm telling you, rearrange the equation algebraically first. Isolate the variable you want to see. This will increase the speed at which you can make your calculations happen, and it also helps when you go to error check. So, I'm looking to find P2, so I'm going to divide both sides by V2. If I do that, I get P1 V1 over V2 is equal to P2. And when I plug in all those numbers, I can see from a unit analysis that my liters will cancel, and I'm left with atmospheres, and the answer will be 0.63 atmospheres with two significant figures. Does this make sense? Well, as pressure goes up, volume goes down. That means that as volume goes up, which volume went up, the pressure must go down. And 3.1 is certainly bigger than the 0.63 of our new pressure. Now, Boyle's Law is infinitely important to us as human beings because we inhale breaths, which is just a function of Boyle's Law. When you inhale, air goes into your mouth and nose. Why? Well, because your diaphragm moves down. As the diaphragm moves down, volume increases. When volume increases, that means that the pressure must decrease. And what that means is that the external air pressure gets forced down into our lungs to be disseminated there, to equalize the external pressure. Breathe out, the diaphragm moves up. Diaphragm moves up, volume decreases. Therefore, the pressure must increase. It's higher than the external pressure, so the air comes out our mouth and nose. So this was our introduction to Boyle's Law. It's a very important law. It is a pressure volume law, and you should do as many Boyle's Law problems as you can get your hands on. And remember to always rearrange your variables before plugging in your numbers. And from here you should go to the next video in which we're going to be talking about volume and temperature.